Hi folks, today I'm going to show you how you can use a push button and a switch and control the LED in TinkerCAD. So let's head to the circuits. If you are new to the TinkerCAD, you might want to join and create a new account. Once you have it and you log in, it will take you to a page which would look something like this. You then create new circuit by clicking here. And then what I'm going to do is I'm going to pull a breadboard from here, drag it over here. I need a push button and an LED and a power supply to complete the circuit. So let's get started. We'll also need a resistor because the voltage drop across LED needs to be at least 1.8 and we would need a power supply. I'll use this 9 volt. If you press Shift R, you can change the orientation of any component. And the last thing we need is a push button here. I'm going to place my push button right here. Notice this is cathode, this is anode. Many students get this wrong. This is the anode positive and this is the cathode negative. Okay. Similarly, I'm going to rotate the direction of the resistor. Press Shift R, and then this is going to be over here. This is connected to the positive terminal, and the negative terminal of the LED is going to be connected to that ground. Now this is the negative terminal of the battery. Let's make a connection to the negative rail on the breadboard. If you want to change the color from green to black, you can do that by using this drop down arrow. I'm now going to make connection for the positive terminal of the battery. Let me go this way. And then this is the positive terminal of the battery. So I'm going to change the color to red so I know. And if you wish, you can short the two positives and the two negatives so you can use both the rails on each side of the breadboard. Now, how you make connections when you are using a push button. Remember, the goal of this project is when the push button is pressed, the LED lights up. So we use cross connections. So this would mean this needs to be connected to the VCC, which is going to be 9 volts in our case. Again, here I'm going to change the color. So actually this needs to be negative, negative, and positive, positive. Okay, this is the negative, so it needs to be black. This is the positive rail, so those needs to be red. Everything looks okay here. I have connected the signal to 5 volt, to 9 volt. And this is going to be connected to this resistor right here. Now 9 volt, when this button is pressed, the 9 volt will go past this push button and then goes to the resistor. Your LED needs only 1.8 volt, so rest of the voltage drop is going to be across this resistor right here. So I'm just gonna, 1K would work here. Now your circuit is ready. And again, this is because it's the cathode, so it needs to be black. And that's pretty much it, folks. That's a very simple circuit. Remember, push button is a mechanical device, and the way it works, when the user presses the button, it actually just closes the contact. So metal contacts are then in touch, and then this 9 volt will go past close contact and then go past this resistor and then going into the LED. The only purpose of using this resistor is we don't want to burn our LED because 9 volt is way too much. It only needs about 1.8 to 2 volts. Okay, so now once the circuit is ready, you then click on Start Simulation, and then let's test the circuit. When I press the button, LED goes on. Let's press it again, the LED goes on. If I hold the button for a long time, the LED will stay on. And as soon as I release the button, that is when the LED goes off. So a very simple and easy way of using push button. Now I'm going to show you how you can do the same thing but with a switch. So I'm going to stop the simulation. I'm going to go to my search toolbar and then type switch. Here's the switch, and I'm going to place it maybe somewhere over here. Yeah, that's right here. Notice it has 3 terminals. Okay, one says terminal 1, one is the common, and the other one is says terminal 2. We're only going to use the 2 terminal. We only use either the first 2 from the left, or you use the 2 from the right. Now the first terminal is going to be connected to the positive terminal of the battery, so I'm going to make it red. The common terminal is going to be connected to this resistor right here, okay? And that's pretty much it. So 9 volt comes in, and whenever the switch is on, then that 9 volt will travel, go past this resistor, and then this resistor is connected to the positive terminal of the LED, and the negative terminal of the battery is connected to the cathode, which is the negative terminal of the battery. So let's see if this works. Okay, I'm gonna run the simulation, and notice as soon as I clicked on the simulation, the LED turned on. So this would mean it's right on. So if I switch the lever to the other side, it should go off, which it does. Okay, so I'm gonna turn it on back again, turn it off back again. Now what happens if I change the pins, or if I use different terminals? Instead of using this one, if I use this terminal and then connect it to the positive terminal of the battery, then what happens? Well, let's see. I'm gonna click on simulation. Well, notice this time when I clicked on the simulation, the LED didn't turn off. So if I change the lever to the right hand side, move it to the right hand side, which it does, now LED blinks. Okay, so now you know how you can use these terminals to get to switch to work. So that's a very simple demonstration of how to get started on push buttons and switch in TinkerCAD. Same thing applies on any circuit that you may be working with, either in integration with Arduino or Raspberry Pi or any other device that you may be using. Also, if you wish to see your signal or a voltage that's going through your LED, you can also use a multimeter or even oscilloscope, and I'll show you both ways you can do it. So let's pick an oscilloscope, and we want to see the signal going into LED. So this is a positive terminal. I'm going to connect it to the anode, positive terminal of the LED, and then negative terminal could just be connected to the ground. Now I'm going to start the simulation here, and I'm going to press the button. There you go. Notice the signal was flat, and as I am actually pressing the button, it went up. Okay, let's see again. You see it goes from 0 to some voltage. If I press it again, you again see the same thing. Let's do with the switch as well. Okay, there you go. Here's the shift going from 0 to whatever voltage it is. Now it's off, so you see a flat line, right? We can also test it using a multimeter. So let me pull that multimeter. I'm going to connect the negative terminal to the negative rail, then positive terminal to the positive terminal of the LED. Okay, alright, let's now start the same thing. Run the simulation. It's 88.7 millivolt, almost close to 0 volt. When I press the push button, LED goes on, and you see the voltage drop is around 1.95. I initially told you 1.8, and that's what it is. It could be anywhere few hundred millivolts above and below, and that's what you see over here. Let's try this with the switch, and we're getting the same voltage drop. That's pretty much it, folks. Thank you for watching.